Hello everyone. Looking at the map right now, there's a pretty clear shift happening across North America. This is something that's been developing, and today we can really see it taking shape. What we're observing here represents a significant change from the patterns we've been tracking over the past several days. So let's dive right into what we're seeing here. When I look at the broader picture across North America, there's a large-scale weather pattern change that's becoming quite evident. This isn't something that's isolated to just one spot. We're looking at a continental-scale influence that's stretching from Canada down toward the United States. This type of wide-reaching pattern is exactly the kind of thing that can influence conditions across multiple regions simultaneously. The scope of what we're seeing here is really quite remarkable. The atmospheric setup spans from the Pacific Northwest all the way across to the Atlantic seaboard. When patterns organize themselves on this kind of scale, they tend to have more persistence and broader impacts than smaller, more localized systems. This continental-wide organization suggests we're dealing with a significant atmospheric reorganization that could influence weather patterns for an extended period. What's particularly striking about this setup is how well-defined the various zones are becoming. The contrast between different air masses is sharp enough that we can clearly identify boundaries and transition zones across the map. This level of definition usually indicates that the atmospheric pattern is becoming more mature and organized rather than just being in the early stages of development. Now, if we trace back where this is all coming from, the source becomes pretty apparent. The cold air mass that's driving this whole setup has its origins clearly positioned over Canada. What's interesting here is that this isn't a static situation. This cold air mass is creating a southward pressure, and we can see that influence becoming more pronounced as it approaches the northern border of the United States. The Canadian source region appears to be quite robust, which is significant because it suggests this isn't just a weak or temporary feature. When we see cold air masses with this kind of strength and organization over Canada, they typically have enough energy to maintain their characteristics as they move southward. This persistence is important because it means the effects we're seeing aren't likely to dissipate quickly. Looking at the structure of this cold air mass, it's not just a shallow feature. The depth and extent of the cold air suggests we're dealing with a substantial atmospheric feature that has significant influence over surrounding regions. This kind of three-dimensional structure is what gives these systems their staying power and their ability to affect such large geographic areas. The pathway this cold air is taking is also noteworthy. Rather than moving in a narrow corridor, it's spreading out as it moves southward, which means its influence will be felt across a broader area. This spreading pattern is typical of strong continental air masses and indicates that multiple regions will experience the effects of this system. This kind of pattern tells us that the atmospheric setup is actively pushing this cold air toward the south, rather than just sitting in place. The dynamics we're seeing suggest there's genuine movement happening here, and that movement has implications for what we might expect in the coming period. The speed and direction of this movement will be key factors in determining how quickly conditions change across different regions. Let me direct your attention to the northern sections of the United States, particularly areas like the Midwest, the Northern Plains, and around the Great Lakes region. Here's where things get really interesting from an analysis standpoint. Looking at these areas on the map, we can see the transition lines are becoming much more compressed. This tightening of the gradient lines indicates that weather conditions in these regions could become more variable. The Great Lakes region is showing particularly interesting characteristics. The interaction between the cold air mass and the relatively warm lake waters is creating some unique patterns that we can observe on the map. These lake effect influences are adding complexity to the overall pattern and could lead to some localized variations in conditions across this region. Moving into the northern plains, the pattern shows a different character. Here, the cold air influence appears to be more direct and less modified by local geographic features. This suggests that areas in the northern plains might experience more uniform conditions as this pattern evolves, though still within the broader framework of variability we're seeing across the northern tier. The Midwest is showing an interesting blend of characteristics. Parts of this region are experiencing the more direct influence of the cold air mass, while other areas are in transition zones where different air masses are interacting. This creates a patchwork of conditions that makes the Midwest particularly interesting to monitor as this pattern continues to develop. The cold air influence is expanding into these areas, but what I'm noticing is that the system doesn't appear to be completely settled yet. This suggests we're looking at regions that could experience some degree of changeability. These are definitely areas that warrant close monitoring, because when you see these kinds of compressed gradients, it often means the atmosphere is in a more active state. The pattern suggests there's still some movement and organization happening, rather than everything being locked into place. This type of setup often means conditions can shift relatively quickly, so these northern regions are particularly worth keeping an eye on. The dynamic nature of what we're seeing suggests that the situation could continue to evolve over the next several days. Moving our attention eastward, there's another really notable feature developing across the eastern portions of the United States. Here we can see a boundary forming between the cold air and the more moderate air that's been in place. What's particularly interesting about this boundary is how defined it is, but also how it appears to be mobile rather than stationary. The eastern seaboard is showing some particularly complex patterns. The interaction between the continental air mass and the maritime influences from the Atlantic is creating a dynamic setup along the coast. This interaction often leads to interesting weather developments, and the current pattern suggests this region could see some notable changes as the system continues to organize. Further inland across the eastern regions, the boundary characteristics are somewhat different. Here, the transition between air masses appears more gradual, which might mean changes in these areas could be more subtle, but potentially more sustained. The topography of the Appalachian region is also playing a role in how this boundary is positioned and how it might move. This line we're seeing isn't fixed in place. The characteristics of this boundary suggest it has the potential to shift position over time. When we see boundaries like this that aren't anchored, it often indicates that weather conditions along and near this line could experience some relatively quick changes. The mobility of this boundary is one of the key features that makes this pattern particularly interesting to track. The positioning and movement of this boundary will likely be a key factor in determining how conditions evolve across the eastern regions. Areas near this transition zone should be prepared for the possibility of changing conditions, since these types of mobile boundaries can bring shifts that develop over shorter timeframes. The timing and extent of any movement will depend on how the broader atmospheric pattern continues to develop. This isn't necessarily a cause for concern, but it is definitely something that makes this region worth monitoring more closely than areas where the pattern appears more stable. The potential for change is always higher near these active boundaries, and residents in these areas benefit from staying informed about how the situation is evolving. Now, when we look toward the western and central portions of the United States, we're seeing a somewhat different story. In these regions, the cold air appears to have a more established presence. The pattern here looks more uniform and settled compared to what we're observing in other areas. This stability creates an interesting contrast with the more dynamic regions we've been discussing. The Rocky Mountain region is playing an important role in this overall pattern. The terrain is helping to organize the airflow and creating some predictable effects on how the cold air mass behaves as it encounters these geographic features. This topographic influence often helps stabilize patterns and can make conditions in these areas more predictable over longer periods. Across the Central Plains, the pattern shows good organization and consistency. The lack of major topographic barriers in this region allows the air mass to maintain its characteristics more easily, which contributes to the more stable appearance we're seeing here. This doesn't mean conditions are unchanging, but rather that any changes are likely to be more gradual and predictable. This more stable appearance suggests that these western and interior regions may experience less dramatic changes in the near term. Rather than seeing the kind of active boundaries and compressed gradients we noted in other areas, the pattern here appears more consistent. This consistency can be valuable for planning and preparation purposes. This doesn't mean these areas are immune to changes, but the current setup suggests that any evolution in these regions would likely be more gradual. The atmosphere appears to be in a more organized state here, which typically translates to conditions that change more slowly and predictably. This predictability is often a characteristic of well-established air mass influences. For residents in these areas, this more stable pattern might mean fewer surprises in terms of sudden weather changes, at least based on what we're currently seeing on the map. However, it's important to remember that even stable patterns can evolve, and continued monitoring is always advisable. What makes this entire setup particularly noteworthy is how clearly we can see the different characteristics across these various regions. The contrast between the more active zones and the more stable areas really stands out when you examine the map as a whole. This kind of regional diversity within a continental scale pattern is fascinating from a meteorological perspective. This type of continental scale organization doesn't happen every day, and when we do see patterns like this, they tend to have staying power. That means the general characteristics we're observing now could influence conditions for several days ahead. The persistence of large-scale patterns is one reason why understanding these broader setups is so valuable. The key thing to understand is that while some areas are seeing more active patterns, others are experiencing more settled conditions. This regional variation is actually quite common with these larger scale setups, and it's why looking at the broader picture is so important for understanding what might develop. Each region's unique characteristics contribute to how it responds to the overall pattern. Each region is responding differently to the overall atmospheric pattern, and that's creating these distinct zones of behavior we can see across the map. This variety is exactly what we'd expect with this type of setup. The interplay between the large-scale pattern and local geographic influences creates this complex but organized picture we're seeing today. Looking ahead, this pattern will likely continue to evolve. But the fundamental structure we're seeing today gives us good insight into the general direction things are heading. The boundaries we've identified will probably continue to be important features, and the source region of this cold air will remain a key factor in how things develop. Understanding these fundamental drivers helps us anticipate how the pattern might change over time. The areas we've highlighted as more active will probably stay worth watching, while the more stable regions will likely maintain their current characteristics, at least in the immediate term. This doesn't mean conditions will remain exactly the same, but rather that changes are likely to occur within the framework of the current pattern structure. This is definitely a pattern that merits continued attention over the next several days. The combination of the large-scale organization and the regional variations we're seeing makes this a particularly interesting setup from a meteorological perspective. We'll continue monitoring how this evolves, especially in those transition zones where we're seeing the more active patterns. Those areas will probably give us the best indication of how this broader pattern continues to develop going forward. By watching these key regions, we can better understand the overall evolution of this continental-scale weather pattern.